Imagine, if you will, a future where technology has transcended beyond our wildest dreams. Would that future be dominated by quantum computers, or would artificial intelligence reign supreme? In the boundless universe of technology, two celestial bodies have been steadily gaining momentum, poised to reshape the future as we know it. These two technological titans are none other than quantum computing and artificial intelligence. Quantum computing, a field that leverages the principles of quantum mechanics, is like a mythical beast in the tech world. Its potential power and speed are touted to surpass the capabilities of our current computers, promising to solve problems that are presently too complex or time-consuming for conventional machines. Quantum computers could potentially revolutionize fields like cryptography, optimization, and drug discovery, to name a few. On the other hand, we have artificial intelligence, the brainchild of our technological advancements. It's the idea of creating machines that can think, learn, and adapt like humans. AI has already started making its mark, automating tasks, enhancing decision-making, and even creating art. The potential applications for AI are vast, from autonomous vehicles and personalized medicine to highly efficient energy systems and beyond. But it's not just about what each of these technologies can do on their own. It's also about how they could interact, intersect, and possibly even intertwine. Could quantum computing power the next evolution of AI? Or could AI find ways to optimize and advance quantum computing? As we stand on the precipice of this technological revolution, these questions become increasingly critical. These are not just academic or theoretical inquiries. They are questions about our future, about the kind of world we're shaping with these technological leaps. So, buckle up, tech enthusiasts, future gazers, and curious minds. This is not just a journey into the realms of quantum computing and artificial intelligence. It's a voyage into the future of technology itself. Prepare to dive deep into the world of quantum computing and artificial intelligence. Scene script. Picture a computer that can process information millions of times faster than the most powerful supercomputer today. That, in essence, is a quantum computer. So what makes a quantum computer so special? To understand that, let's take a step back and talk about classical computers first. They process information in binary digits or bits, which can be either a 0 or a 1. However, quantum computers use quantum bits or qubits. Unlike classical bits, a qubit can be both 0 and 1 at the same time, thanks to a quantum quirk known as superposition. Imagine a spinning coin. While it's in the air, you can't definitively say if it's heads or tails. It's essentially both. That's similar to the state of a qubit in superposition. But once the coin lands, it's either heads or tails. Similarly, when a qubit is measured, it collapses to being either a 0 or a 1. Now here's the kicker. Because a qubit can exist in multiple states at once, it can process a vast amount of information simultaneously. This is where quantum computers gain their extraordinary processing power. But there's more. Quantum computers also exploit another quantum property called entanglement. When qubits become entangled, the state of one qubit becomes connected to the state of another, no matter how far apart they are. This allows quantum computers to perform complex calculations at a lightning-fast speed. However, it's important to note that quantum computers aren't just faster versions of classical computers. They operate in an entirely different way, solving problems that are currently beyond the reach of classical machines. So, this is what makes quantum computers a game changer. They aren't limited to binary choices. They embrace the complexity of the quantum world, where things can be in multiple states at once, interconnected in ways that boggle the mind. Quantum computers could potentially revolutionize everything from drug discovery to climate modeling. And that, my friends, is the power and promise of quantum computing. If quantum computing is about processing power, artificial intelligence is all about mimicking human intelligence. Artificial intelligence, or AI as it's more commonly known, is a broad term that embodies the concept of machines being able to carry out tasks in a way that we would consider smart. It's about creating systems that can understand, learn, plan, and perceive, much like humans do. So how does it work? Well, the magic of AI lies in its ability to learn. This is achieved through a process known as machine learning. Machine learning is a subset of AI and is based on the concept that systems can learn from data, identify patterns, and make decisions with minimal human intervention. Imagine a child learning to recognize objects. They see a ball, someone tells them it's a ball, and after seeing a few more similar objects, they learn to recognize all balls. Machine learning works in a similar way. It's fed data, it processes the data and learns from it. Now, just as the human brain has neurons that process and transmit information, AI uses what we call neural networks. These are complex algorithms designed to replicate the way our brains work, recognizing patterns and classifying data. These networks can learn and adapt over time, constantly improving their performance. But it's not just about mimicking human intelligence. AI is also about surpassing it. With the ability to process vast amounts of data at incredible speeds, AI can find patterns and make connections that would be impossible for a human brain. It's like having a superhuman brain at our disposal. This potential has led to a boom in AI applications, from voice assistants like Siri and Alexa, to self-driving cars, to diagnosing diseases. AI is transforming every industry, every job, and every aspect of our lives. Artificial intelligence is not just about creating machines that think like humans, but machines that can learn and adapt. And as we move forward, the impact of AI on our world will only continue to grow. Now that we understand the basics of quantum computing and artificial intelligence, it's time to pit them against each other. Quantum computing, the brainchild of quantum mechanics, is all about leveraging the power of qubits, particles in a superposition of multiple states simultaneously. This ability to juggle multiple computations at once gives quantum computers a significant edge in solving complex problems that would take classical computers an astronomical amount of time. However, they're not without their share of challenges. Quantum systems are incredibly delicate, susceptible to environmental noise, and require extreme conditions to function, like temperatures colder than outer space. On the other hand, we have artificial intelligence, the darling of computer science. It's all about creating intelligent machines that can learn, reason, and act like humans. AI is already revolutionizing various sectors, from healthcare to finance, and even entertainment. But it's not a silver bullet. AI systems require vast amounts of data to learn effectively, and there's always the risk of them learning and perpetuating biases present in the data they're trained on. Plus, there's the ever-present existential dread of machines becoming too smart for our own good. But enough of the doom and gloom. Let's talk about how these two titans can complement each other. Imagine a world where quantum computers are used to optimize AI algorithms, leading to faster learning and more accurate models. Or consider a scenario where AI is used to manage and control quantum systems, mitigating some of the instability and noise issues. The possibilities are endless, and the synergy between these two fields could well be the key to tackling some of the biggest challenges facing humanity. But let's not get ahead of ourselves. Remember, both these technologies are still in their infancy, and we're only beginning to scratch the surface of their potential. It's going to be a wild ride, and we're all strapped in. Quantum computing and artificial intelligence both have their unique strengths, and their intersection could lead to remarkable advancements. The future of technology is not just about quantum computing or artificial intelligence, it's about how these technologies can work together to create a better world. We're looking at a future where quantum computing, with its ability to perform complex calculations at an unprecedented speed, could be the key to solving some of the most daunting challenges of our time. Imagine a world where we can accurately predict climate patterns, design personalized medical treatments, or even crack previously unsolvable mathematical puzzles. That's the kind of future quantum computing promises. On the other hand, we have artificial intelligence, a technology that is already transforming our world in ways we could hardly have imagined. From autonomous vehicles to voice assistants, AI is making our lives easier, safer, and more efficient. But its potential goes far beyond that. AI could help us make sense of the vast amounts of data we generate every day, uncovering patterns and insights that could lead to breakthroughs in everything from healthcare to finance. But what's truly exciting is not just what these technologies can do on their own, but what they can do together. Imagine a world where quantum computers power artificial intelligence, allowing AI to learn and evolve at a speed and scale we've never seen before. This could unlock new possibilities in fields as diverse as neuroscience, material science, and even space exploration. As we move towards this future, it's crucial that we understand these technologies and their implications. We need to ensure that they're used in ways that benefit all of humanity, not just a select few. We need to consider the ethical implications, the potential risks, and the societal changes they might bring. As we stand on the precipice of a technological revolution, the question isn't whether quantum computing or artificial intelligence will dominate the future, but how we can harness their combined power to shape a better world.